Hi, this is tasks 5 and 6 of the second AAT sample assessment for AMAC. So task 5 is a 20 marker, computer marked, about decision-making techniques. So identify whether the following statements are true or false for short and long-term decisions. So relevant costs are only considered in long-term decisions. No, relevant costs are considered whatever, short or long term, so that must be false. Cash flows are less certain in long-term decisions. Well, yes, because the further into the future you get, the harder it is to predict what's going to happen. Significant capital investment is required in long-term decisions. Yes, because whenever we think about long-term decisions, we're appraising a project. There's usually an outlay and then the corresponding cash inflows. There is no risk with short-term decisions, but there's always risk, so false. Complete the following statement about short-term decision-making. When making short-term decisions, you should include, so short-term decisions, so you should include which one of these, which are, right, so I'm thinking you're looking for the incremental costs, so like over and above, things that are going to be changing as a result of your decision. So when making short-term decisions, you should include so future costs and revenues, which are incremental and only incorporate, so it's cash flows that we include, so cash flows into the calculations. F Limited currently buys in one of its biggest selling products, but is considering whether it would be cheaper to make the product itself. The cost of buying in the product from the external supplier is £12 per unit. F Limited would make and sell 21,000 units each year and has estimated the manufacturing cost detailed in the table. Right, so part C, identify, so bear with me a second, yeah. Just get the answers so that I can check as I go along. I don't want to tell you the wrong thing. Hang on. Here we go. Identify whether each of the following costs are relevant or not relevant to the decision. Okay, so materials then, first of all. Each unit requires 2 kilograms of material. The main supplier would charge £2 per kilo, but can only supply 20,000. The remaining material would cost £3 per kilo. So the cost of the material is going to be relevant. It's an incremental cost. Direct labour. Each unit takes 15 minutes to produce. Production workers are paid £12 per hour. So that's going to be relevant. Supervisor. One of the existing production supervisors would spend 10% of their time on the new product. So if it's an existing supervisor, it's a committed cost already, so therefore it's not relevant. Rent. Extra factory space would be required. So this is an additional cost. Although it's a fixed cost, it's not currently committed, and therefore it is going to be relevant to the decision. Part D, calculate the estimated total manufacturing cost. Right, so materials. So each unit requires 2 kilograms of material. So 2 kilogram times 21,000 units is 42,000 kilograms is needed. The first 20,000 is going to be at £2. So 20,000 times £2 is 40,000 pounds. And then we need another 22,000 kilos at £3 per kilo, which is 66,000 pounds. So altogether, my materials are going to cost 106,000. Right, direct labour. Each unit takes 15 minutes to produce. So let's convert that to hours. So 15 divided by 60 times £12. That's per unit. And then times by the 21,000 units. So that gives me 63,000. Okay, supervisor, we said was not relevant. So therefore we are going to put in 0. And then the factory rent, we're incurring an extra 31,500. So that is going to go into the cost calculation. Identify whether the following assumptions behind the use of linear programming are true or false. So linear programming is the one where you set your objective, usually around maximising contribution. And then you basically write equations for the limitations of maybe demand or how many hours are going in. But the point with linear programming is that you can have more than one limiting factor, although you can only use it to kind of work out for 2 products. So let's have a look at these true or false statements. Linear programming allows for multiple objectives. No, you have one objective, which is usually maximize the contribution. You will have multiple limiting factors, but only one objective. Each product always uses the same quantity of the scarce resource per unit. Yes, because you're drawing straight lines basically and finding where they cross. So when you're drawing a straight line, it's linear. It's called linear programming. So it means that there's no adjustment for bulk discounts or sort of variations in the unit cost. So that one is going to be true. Linear programming can only be used where there is just one scarce resource. No. You use it where there's more than one scarce resource. That's the whole point of it. The contribution per unit is constant. Yes, again, it's linear. So you're working with straight lines. And linear programming ignores fixed costs. Yes, it's a short-term decision tool, and we ignore fixed costs and focus on the marginal costs. Right, so that's the end of that task. Task 6, 14 marks. Again, computer marks, so you won't have to write about any of these topics. The concept of the time value of money states that, so time value of money is sort of linked to inflation, recognizing that money in the future is worth less, the same amount of money in the future is worth less because obviously it doesn't have the same buying power. So which of these is best? Money to be received in the future is worth less than money now and is more certain to be received. Well, it's definitely worth less than money now, but I would say it's less certain to be received. M Limited is deciding whether to launch a new product. Selling price of £70 per unit, variable cost of £20. So we've got a contribution of £50 per unit. Overheads would be 250,000 per year, and we've got forecast sales as shown. The initial investment is £500,000. Right, we need to calculate a non-discounted payback period. So you could be asked for a discounted payback period where you would use your the cash flows would be multiplied by the discount factor to get a discounted figure first. But this one, we don't have to do that. It's non-discounted. And they've given us conveniently a little table here to fill in to work out our payback. Right, so the annual, so right now, I can't put anything in there. So right now, year 0, what is my cash flow? So I'm spending out £500,000. It says use minus signs to indicate cash outflows. So minus 500,000. The cumulative cash flow is just the running total. So one and the same right now. Then we've got an annual overhead there of 250,000 that's been put in for us, which is this figure. We've got to put in what the annual contribution is. So if these are the sales, 5,000 units, and we know that the contribution per unit is £50, we're just going to do 5,000 times 50. So for year 1, that gives us 250,000. In year 2, we're going to do 8,000 units times 50. Oops. And in year 3, we're going to do 12,000 units times 50. And do we need to go any further? Year 4, we could do 10,000 units times 50. And in year 5, I haven't filled these in the mark scheme for some reason. I'm not sure why. I think they must just have left them out because you don't technically need them for the payback. But for exam purposes, if you can fill it in, I'm going to fill it in. Right, so year 5, I've got 7,000 units times 50, which is 350,000. Right, so the annual cash flow will just be the contribution take away the overhead. So 0 in year 1, 150 in year 2. So 600 take away 250 is 350. 500 take away 250. And finally, right. So then the cumulative cash flow, so we had minus 500, zeros flowed in, so we're still on minus 500. 150 has now flowed in, so we're on minus 350. 350 has flowed in, so we're on 0. And then again, they haven't filled this in the mark scheme, but I'm going to add it in because it's allowing me to type in those cells, so why wouldn't I? Right, payback occurs in, it's a nice simple one. Look, it's exactly paid back in year 3. So drop down and I can put that in there. M Limited are evaluating a long-term investment proposal and have calculated the following. Calculate the IRR of the proposed project to 2 decimal places. So the internal rate of return is the point at which, well, the discount rate that you need to give an NPV of exactly 0. So with this data here, sort of on a reasonableness test, so 126 is closer to 0 than 569 is. So I'm going to expect the answer to be somewhere closer to 20%. So somewhere sort of probably between 15 15 to 18%, just at a guess. Conveniently, they've given us the formula. So we can just sort of plug the data into this. So the MPV at the first or the lower discount rate, so we're going to have 569 on the top here. Divide by the difference between the two. Now remember, you're traveling from a minus number to a plus number, so actually we want to add 569 onto 126, which gives us 695,000. So we've got 569 divide by 695. If I just knock off all the zeros, it makes no difference for a division. Multiply by the difference between the discount rates. So 20 take away 10 is 10. So 569 divided by 695 equals, times that by 10, and then add your first discount rate, which is also 10. Right, so if you feed all of that into your calculator, being careful with, you know, the order of operations, you should get an answer of 18.19 to the nearest 2 decimal places.